Hello, Wildcats. This is just an overview of the notes for determining resultant vectors mathematically. So, even though we've been doing things graphically, that's fine for a general sense, but when we start to draw things, we introduce error. Like, there's just imprecision inherent in the way that we draw things and how we view the ruler. And so math is a better, more accurate way for us to determine what a resultant vector is. And so because we can make triangles out of our resultant vectors, as you can see here, a displacement of 11 kilometers north and 11 kilometers east gives me this resultant right here, and this is a right triangle. So that means we can use the Pythagorean theorem to solve for the magnitude of the hypotenuse, in this case, which is our resultant. So I know you've encountered this in math class before, so we're not going to spend a ton of time on it. I will remind you that Pythagorean theorem tells us that a squared, one side, plus b squared, the other side, is equal to the hypotenuse squared as well. And so we can use this formula if we know two sides, the adjacent and opposite sides of the triangle, which in this case, and up here we do, we know that they're both 11, we could solve for the magnitude of this hypotenuse. A few things to remember. This is only going to work with right triangles, and this is only going to work when we know both sides, or two sides of a triangle. The other thing to just notation-wise, so the two legs of the triangle, or the components here, will be A and B, so in our equation, and the hypotenuse is always going to be C. Okay, so that would give us the magnitude, right? This gives us the magnitude, the size. It tells us, if we're in math class, it tells us the side or the length of this part of the triangle, the hypotenuse of the triangle. But since this is a vector, we need magnitude and direction. And so we can use that with another trigonometric function, and that is inverse tangent. So in this triangle here, we have, again, you can see the adjacent side, because this is the one touching or adjacent to the angle. This is the side opposite of the angle, and then this is the hypotenuse of the triangle. And if you remember way back when, maybe in math class, you talk about the trigonometric functions. You know them all so well. So, ka, toa. So they're back, and we're going to use them frequently. So tangent is equal to, the tangent of an angle is equal to the opposite side of the triangle divided by the adjacent leg of the triangle. And so if we want to know this angle, right, we could, if we know these two sides, we could solve for this angle. So we need to do a little bit of rearranging, right? We maybe have learned it this. Tangent of an angle is equal to the opposite over the adjacent, toa. But we want to solve for theta. So we need to get theta by itself. And to do that, we can't just divide by tangent. Like if you try that in your calculator, take like 3 divided by 5 divided by tangent, it doesn't work. It's not a thing. So what we actually do is we take the opposite of tangent, or the inverse of tangent. And so that is tangent. It's represented on your calculator. It says tangent -1, and it's usually up above the tangent key. So to access it, you would put second tangent, which gives you inverse tangent, and then you could put in the fraction or the opposite over the adjacent. And this is going to give us the angle. So with those two functions, Pythagorean theorem gives us the magnitude of this, and then inverse tangent would give us what angle this is. We can fully describe the resultant vector. So we can do a problem here. A plane travels from Houston, Texas to Washington, D.C. by flying 1,540 kilometers east and then 1,160 kilometers north. What is the total displacement of this? So first, I've drawn my vector with the two resultants, or excuse me, the two components labeled. And then I'm looking for this orange line, and then in order to actually describe it, I also need this angle. So we would the next step would be use Pythagorean theorem to determine the magnitude of the resultant. So A, we'll call this A. So A squared plus B squared equals C squared. So I would put in 1,540 kilometers squared plus 1,160 kilometers squared is equal to C squared. Okay, so now I'm going to have to solve for that, so I'll grab my calculator. And when I put this in, I end up with a huge number. You might not necessarily write this out, but you would end up with 371720 kilometers. But we got to remember that's still, and actually it would be kilometers squared, right? Because this square gets distributed to both the number and the unit. And that's equal to c squared. So in order to solve for just c, or the resultant, I would need to take the square root of both of these sides. So c is going to be equal to, if I take that in my calculator, I end up with 1,900, and going to 3 sig figs, 1,930 kilometers. Notice my kilometers squared, that gets square rooted, so my square goes away, so that's good. I'm left with just kilometers. So this plane looks like it travels between these two. Its initial position and its final position is a displacement of 1,930 kilometers. Okay, but we need that angle to fully describe it, so we would use the inverse tangent function to determine the direction of the resultant. We know, so theta is going to be equal to tangent inverse of, and now so we got to look at our triangle, and this is why having a drawing helps. What is opposite and what is adjacent? So since this is my angle, opposite is going to be 1,160 kilometers. So 1,160 kilometers. And then adjacent is going to be 1,540 kilometers. So if I take that in my calculator, I do the in parentheses first. So 1,160 divided by 1,540 gives me about 7.753. And then I need to take the inverse tangent of this. Again, double check that your calculator is in degrees, because we're working in degrees, not radians here. So when I do that, I get an angle of, 36.988. So we're going to call that 37 degrees. And now I need to give it direction, right? So I'm looking at this angle right here. My pen is here, and I need to raise my pen that direction. So I am east. And what direction of east am I going? I am going north of east. So it looks like this is going to be 37 degrees north of east. So the answer to our question is, if a plane flies from Houston to DC with these two displacements, what is their total displacement? Well, their total displacement is 1,930 kilometers at 37 degrees north of east. So I hope that helps just kind of as you go through and practice solving for resultants using mathematical methods.